All right, guys and girls, let's talk about mid-segments. So this goes on your index card, but let's talk about what a mid-segment is. So it kind of does what it says. It's a middle segment, right? Mid-segment, middle segment. So it's the segment that joins the two midpoints of the other sides together. So if it's a midpoint, it hits exactly in the middle. So the middle of this side is M, and the middle of this side is N. And we draw that segment from M to N. So MN, that line or segment, is the mid-segment. And there are two things that are true when you have a mid-segment. The first thing that is true is it is parallel to the third side. So we can draw in our little arrows. MN is parallel to YZ. Those two segments are parallel, so they never cross. Now, when you have parallel lines, you have a lot of special angles. What are the special angles that we've talked about? Alternate interior. Same side interior. Yeah, that's it. So corresponding alternate interior, alternate exterior, and same side interior. Remember, the first three are congruent, and the last one is supplementary. So you will see some angles that pop up in today, and you may see all four of those or a few of those. Another thing that is true is the mid-segment is half as long as the third side. So I'm just going to add in some numbers here and we can see how they compare. Let's say our mid-segment has a length of 5 units. What would be the length of the third side? 10. So we can double the mid-segment to make the third side. Or if we know the third side is 10, then the mid-segment would be half of it. So it would be 5. So remember, the mid-segment is the middle. So it's halfway between like the highest point on the triangle and then the base of that triangle. So they're parallel and half as much. Does that make sense? All right. The rest of our notes that we're going to have will be on our notebook paper. So let's look at some examples. So let's try this first one if it decides to pop up. My board likes to freeze here lately. I need to get the tech guy in to look at it. Now, keep your index card out to the side while you do the rest of the notes so that way you can refer back to it. But the two main points, the third side's parallel and it is half as long. All right, here are the 3 examples. Write these down. You don't have to have much room underneath them, and you don't really even need to make them that big. So if you want to put these 3 side by side like they are on the board, that would be good. Oh, there you go. So sketch those real quick. They don't have to be perfect. Just sketch them. Now you may notice all those little marks that are on the side of your triangles, right? Those little lines, red and blue. So you have to show that you have a mid-segment in order to use those rules about mid-segment. So remember, a mid-segment splits a side in half. It finds the middle of one side, finds the middle of the other side, and then has that line that connects. So all 3 of these examples, because of all those little red and blue lines, it's showing us that we have a mid-segment. Okay? So in the first example, are we given the mid-segment or the third side? We're given the third side of the triangle, right? Because it's part of that big triangle piece. So what do we do with the third side to get the mid-segment? We take half of it. So what's half of 24? 12. That's the answer. If it is simple math like that, you do not have to show any work. So the simple math is take half the third side, we get the mid segment or the middle. Okay, let's look at number 2. Well, what are we given? We're given the mid segment is 15, right? What should we do with the mid segment to make the third side? We multiply it by 2. So if you need to, you can put like little arrows in there and you can hit times 2. And then over here, if we go backwards this way, we divide by 2. So we take half or we multiply. So what's 15 times 2? 30. So we would say 3x equals 30. So we multiply that mid-segment times 2, and then we have an equation set up, and we would just need to divide, so x equals 10. And that's how we would get our answer. So look at what you have. If you have the longer piece, you divide by 2 to make the shorter piece. If you got the shorter piece, you multiply by 2 to make the longer piece. I would write it down on tests and quizzes. This one is pretty simple that I would say you wouldn't have to either. So that would be fine to just have the answer. But if you see a problem like number 3, you definitely want to write it down. Now, what would be easier in number 3? Would it be easier to divide the third side by 2, or would it be easier to multiply the mid-segment by 2? I think it's always easier to multiply, right, than divide. Think about when you were in elementary school. It was easier to multiply, right, instead of going backwards. So when you see a problem like this, definitely set it up. We're going to multiply the mid-segment by 2 to equal our third side. So multiplying by 2 means that you're multiplying everything by 2, so keep that in parentheses. So let's distribute, and we get and then what would you do to solve? Subtract the 2x. Good. So 6 equals 2x minus 16. So next we add 16. And you don't have to show this like extra work here, but if you want to, that's perfectly fine, like minus 2x and add 16. But you should show some logical steps to get from one to the other. So what is 6 plus 16? 22 equals 2x in last step. Divide by 2, so x is 11. Now, because it has x with it, it may ask you to plug it back in and figure out the length of those segments. So if I were to plug 11 back in, what is 11 plus 3? 14. And then that means this side should equal what? 28. Let's double check. What's 4 times 11? 44. What's 44 minus 16? 28. So this side equals 28. So it's always great to plug it back in and double check it and make sure that you get the right thing. Okay? Does that make sense? Okay. So if you see problems like this on your homework, just remember you're either doubling the mid-segment, the shorter piece, to make the third side the longer piece, or you take the longer piece, the third side, divide it by 2 to get the shorter side. So you're either multiplying or dividing. All right, number 4 is there. Y'all don't need this one yet, so let's just ignore that one for a second. So write down all those words and draw that picture. The picture doesn't have to be drawn real big, but write down all those words and draw that picture. Okay, so it's got to give us that information at the very beginning. M, N, and P are midpoints. So since it tells us that they're midpoints, we know that we have some mid-segments there. So as long as each side is hit in the middle and you connect them, we have our different mid-segments. Now, looking at this picture, we saw ones basically where the mid-segment and the third side were pretty much one in each picture, right? But now, how many mid-segments do we have in this picture? 3. Now, read the first point on your index card. What's the first thing say? Parallel to the third side. So the ones that are parallel to each other are the relative mid-segments that go with that third side. So when we look at MN right there in the middle of the triangle, it is parallel to side XZ. So MN and XZ are mid-segment third side. So when I look and kind of turn my triangle, when I look at MP, MP is parallel to YZ. So that's the third side that goes along with it. Okay? And then NP and XY would be mid-segment third side. So up here at the top, it also tells us that the perimeter of MNP is 60. So MNP is the smaller triangle here in the middle. And it said the perimeter was 60. What is perimeter? All sides added up together, right? So 15, 28, and something else will make 60. So the first thing that I want to do is find this something else side. Let's find this NP side. So if this perimeter is 60, we would just add 28 and 15. So what's 28 and 15? 43, good. And then we would subtract from 60. So what's 60 minus 43? 17. So this third side here is 17. Not necessarily drawn to scale, but close enough. Okay, so our question here says, find NP and YZ. So we just found NP, right? NP is 17. So now we want to find YZ. So YZ is this whole side. Now what does this whole side relate to? 28, because that's the parallel. Does that mean that YZ is also 28? No. What is YZ? Double it. So what's 28 doubled? 56. So this whole side is 56. There's also one other thing that I want to show you guys. So since this is the midpoint, N is the midpoint, means 56 gets split in half. Well, what's half of 56? 28. So this part's 28, and this part's 28. So this mid-segment is actually equal to those two other segments that you have on the third side. But when you add them up together, it makes 56. I have a lot of students do a mistake on this one, and they say, well, if this is 28, then this whole side is 28. But would that make sense? This smaller segment is the same length as this bigger segment? No. So it's double. So don't forget to write up here at the top, YZ is 56. So in tonight's homework, make sure you answer all the questions and all the parts. All right, write down problem 5. Now we're going to be finding some angles. Now, what fact is going to help us find angles? Look at your index card. What fact can help us determine the angles? Knowing that some things will equal 180, yes. And what's the first thing on your index card say? Parallel. And when we have parallel lines, we have our 3 or 4 special angles. What are our 3 or 4 special angles? So when you see parallel lines, we have corresponding angles, well, not adjacent, but same side interior, which are supplementary, alternate interior, and alternate exterior. So when you're trying to find angles, the only angles we've talked about this week are those 4 main ones, and those come about when we have parallel lines. So key thing on this one is mark those parallel lines. Your mid-segment is parallel to the third side. So if you have parallel lines, you can find all your angles in this picture. So the first one it asks us to find is angle AMN. Where is angle AMN? What letter is it at? Is it at B? Yeah, it's at M, right? AMN. If we were to trace it out, AMN. M is the middle, so it is the vertex. So we're talking about this angle right here at M that opens up to A and N. Okay, how can we find the measure of this angle? Well, we know these two lines are parallel, and the only angle that we have down here on those parallel lines is this 75. So what does that mean about this angle right here? Why is it 75? It's corresponding. These two are corresponding angles. So whatever's down here in this corner will always be the same as what's up here in this corner with the mid-segment. So angle AMN is 75 degrees. Now let's find angle ANM. So what angle is that one referring to? N, the angle at N, and it's the upper one at N. So this angle right here. How can we find this angle? You could find angle C, and angle C would be the same as the angle that we marked, right? These two are equal, again, because of corresponding. And so how could we find angle C? Well, think about a triangle, like you discovered yesterday. What do you know about a triangle? All the angles together make 180. Now, you could focus on the smaller triangle up here at the top, or you could focus on the big triangle. Either way, you have the same angles. So we got 40 and 75. Add those together. What's 40 and 75? 115, and then we would subtract that from 180. So what's 180 minus 115? 65. So this angle at N is 65 degrees, which is the same as the angle at C. Although it didn't ask us this question, I would like for us to find the angles that are below the 75 and 65 here in the middle. How can I find this angle below the 75 degrees at M? Subtract it from 180. What's 180 minus 75? 105. So this angle would be 105 because that makes a linear pair. What about this one over here below the 65? 115, because that makes a linear pair. So if you need to, make yourself a little note. Even though I don't write it down on the board usually, you can make yourself a note about what type of angles that you have there. So those two at N and those two at M make a linear pair, and then that can help you find all the angles in the picture. But the key thing are these two angles, this 75 and this 75, are corresponding angles because of those parallel lines. That should be an N. I ran off the picture, so it got a little confused. All right, any questions? All right, I want you guys to make some groups and do this one together. So Amelia, just why don't you come up here with this group and y'all four work together, and then why don't Gracie and Lynn, y'all work with Piper and Melanie, and then y'all four work together. Okay, so write these down, answer all 6 of these questions together. how we did on them. So the first thing says, name all pairs of parallel segments. So what are the segments that are parallel? Melanie, you want to give me one? That's a G. Yeah. Good. HG and TS. Now, you can write these a couple of different ways. It doesn't matter which letter comes first. So HG is parallel to TS. You, again, could reverse those letters. All right. Give me another one besides Melanie. Somebody else? Aiden? RT and HI. Perfect. So RT is parallel to HI. Again, you could have reversed those letters. And there's one more. What's the third one? RS and GI. So RS is parallel to GI. There you go. So notice all three, right, are parallel. Because you all draw parallel lines in the air for me all the time. When I say, what does it look like to be parallel? What do y'all do? That's it. So remember, it doesn't have to be just two horizontal lines. You could kind of turn these and curve them. So every mid-segment is parallel to every third side. So if you have one line like RT, which is kind of slanted, then you have another slanted that goes together. All right, let's look at the next piece here. It says GH is 20. So this whole side is 20. Before I move on to the next part, you can go back and look what we did in example 4. If you know a whole side, like this whole side was 56, how did we get the 28? Dividing it by 2. So this is how we can use a previous example. So that means GR is how much? 10. And RH is how much? 10. And the parallel part, we said GH was parallel to TS. So TS would be 10. Okay. Now, the other part that we have that they gave us was HI is 18. So H to I is 18, which means HS is how much? SI is how much? And which is parallel, RT is how much? 9. So the question asks to find RT. What is RT? 9. What information did I not need for this? I didn't need GH at all. GH is not parallel. I didn't even need that info. The only thing I needed was if I know HI, the third side is 18, I take half of it, and it makes that mid-segment, which is RT. All right. Let me erase this and let's look at the next problem. So the next problem gives us RH is 7. So if I know that's 7, what else do I know? RG is 7. What else do I know? ST is 7. And I could even go ahead and put HG in here, which would be 14. Now, what does the question ask us for? ST. Do I already know what ST is? ST is how much? 7. Did I need this information about RS being 5? No. So sometimes it gives you more than you need. Now, the next problem is talking about angles. So when we talk about angle measurements, we need to refer to the first statement, which lines are parallel. Okay, so it gives us angle G is 60. Angle I is 70. Find GTR. This is the angle that we need right here. Now, if we go back to the one that we talked about with angles, that's the last problem that we did. We said these two are corresponding, right? If you turn your paper sideways, does it still make a triangle? And where are the angles that are corresponding? They're still in the same location, right? So imagine that we have this one now, and we turn our paper sideways a little bit to make it look like the angles that we had before. What is the measure of angle T? 70, because these two are Corresponding. So it doesn't matter if you have your parallels horizontally or to the side or however, those are corresponding. Now, some of you were trying to find some other angles in there, and that was great. Some of you said, well, since that's 70, this is 70, and this would be 60, which could help us find this angle up here at the top. What's 60 and 70? 130, and so angle at the top would be 50. Now, what's neat about these little triangles that we make here? They all have the same angles. So we said this is 60, this is 70. What's this one? 50. Guess what this one is on the other side of T? 60. Guess what this one is up here at S? 50. See how all of those have the same angle measurements. Kind of neat, huh? And it's caused those parallel lines, and it makes those corresponding angles. So the angle that we were missing here was 70 degrees. All right, let's look at our next one. This one says angle H is 50, and angle I is 66. Now find angle ITS. That's this angle right here, ITS. This angle is equal to what other angle? Angle G, which is also equal to what other angle? R, the top angle there at R. But if we know it's equal to angle G, we have a big triangle here. And we know two angles. Can we find the third? Yes, because all the angles in a triangle add up to be 180. So grab those calculators. What's 180 minus 50 minus 66? 64. So this angle here at G is 64, which means the angle over here at T is also 64. Whoop. All right, last one we got here. Angle G is equal to angle H, which is equal to angle I. So all three of these have the same angle measurement, right? What's the only number that all three of those could be that are all the same that make 180? 60. So all of those angles are 60 degrees. 60, 60, 60. Now, we haven't quite talked about this yet, but do you know what kind of triangle it is when all the angles are the same? It's equilateral. What does it mean to be equilateral? All the sides are equal. If all the angles are equal, all the sides are equal. So, RT is how much? 15. This segment right here is 15, which means what? Now we're back to thinking about segments. The length of that segment is like 15 inches or 15 centimeters. HI is 30. That parallel side is double. This side is 30, which means that all the sides are how much? 30. So this one says find the perimeter. How do we find perimeter? Add them all up, and it wants the perimeter of GHI. So if that part's 30, this part's 30, and this part's 30, 30, 30, 30 makes 90. Okay, does that make a little bit more sense now? Okay, some of you struggled on some of those, but some of you found some good angles. Like I heard Melanie over there saying, well, that one's got to be 64 degrees. So I heard that. Heard you guys talking about your parallel segments. So remember, look for those that are in kind of the same location. And then I heard several of you say, hey, I don't even need that info. We don't need that. Just look at the part that you have. So if we all come together, we'll all get it down. Okay, you got some homework to work on. Don't overthink the homework. There it is, page 328. Also, don't forget last night's homework about triangle angle sum is also due tomorrow if you did not turn it in already. Okay, answer key is up here on the box so you can check. And numbers, I know it looks like a lot of problems, but numbers 9 through 19 are like very quick, one little answer. Now, Remember, I got a little note here on the board. If you are solving for a variable, you must write the equation and show your work to solve to receive full credit. If you just write x equals a number, I'm not going to give you credit anymore. So if there's an equation in there that has x in it, you better write it down and show some work. And if you get confused, you can always check up here with the answer key and be like, oh, Miss Cook showed work for that problem. I guess I should too.